So there are 4 new drivers that we'll be discussing today. The first one is IEC-61850 driver, which is ideal for power monitoring and lets you connect to virtually any IEC-enabled device. Next is the Micro800 driver, which you can use to connect to Micro800 devices, of course, without having to use Modbus. The Micro800 driver lets you browse tags and access all data types from the controller, which is really convenient. There's also the DNP3 driver. It features class-based polling, and you can use it to connect to any DNP3 outstation. And finally, the Mitsubishi Driver, which lets you expand your connectivity across the world by integrating ignition with the majority of Mitsubishi series of the MELSEC PLCs. So to kick things off, I'm actually going to hand it back over to you, Tom, to talk a little bit about the IEC-61850 driver.
Sounds great. And yeah, so today our first driver focus, like Reese said, is the IEC-61850 driver, which made its debut early last year in version 8.1.25. Much like the rest of our suite, it's included in the core platform of ignition. This means no additional cost for utilizing it, whether you're upgrading or installing ignition from scratch. IEC-61850 is a protocol widely recognized in the power systems, particularly suited for electrical substation automation. Defined by the International Electrotechnical Commission, or the IEC, an IEC-61850 type device, also known as an IED or intelligent electronic device, encompasses any device equipped with one or more processors capable of sending or receiving data to or from external sources. Now, why is the IEC-61850 driver significant? It's tailored for power monitoring applications, making it a cornerstone in power and power distribution systems due to its interoperability. Our driver only supports MMS, or manufacturing message specification. MMS communication offers meticulous control over data flow from the source to the destination through its own internal reports. This event-based communication, primarily client-server oriented, ensures efficient interaction between ignition as the client and the server, the IED. What sets MMS apart is its ability to confirm data transmission, a critical aspect in control and monitoring systems. This confirmation ensures the reliability and integrity of transmitted information, a vital factor in mission-critical scenarios like power substations. So the IEC-61850 driver comes with multiple built-in system functions that we'll demonstrate a little bit later in this demo, but I'll get into a little bit of the explanation on what each one of these does within ignition. So the get control params system function is very handy in defining the parameters utilized in some of the other functions. It outputs a list of dictionaries that contains all logical devices connected to the IED and their parameters. So if we look at the select, cancel, and operate functions, they give us the ability to toggle the value or state of a logical device. So if we think of a breaker, we can open and close it with this IEC-61850 operate function. For SOB, or select before operating logical devices, we can utilize the system.IEC-61850 select function, which is required to operate that logical device on the control model defined in the SCD file. And we'll get into a little bit more on that SCD file here in a little bit. The cancel function reverts the selection of the logical device, meaning the user will have to reselect the SOB logical device before operating. Many IEC-61850 devices can be set up to produce their own data files in the event of an incident. So it can produce its own PDF or text files. The list files, read file, and write file functions can be utilized to interact with these files to and from the device. So the next driver on the list that we're going to cover is our Micro800 driver. We've been eagerly anticipating the release of the Micro800. So the Micro800 is Allen Bradley's series of a lower cost solution. But until now, like Reese stated earlier, It's been limited to connectivity with ignition solely via Modbus. The Micro800 driver marks the latest addition to IE's driver suite, poised to release in version 8.1.39. However, you could take it for a test drive today by utilizing the release candidate for 8.1.39, available to download on our website today. The driver facilitates seamless communication with Allen Bradley Micro800 PLCs via Ethernet IP over TCP, extending capability to models such as the Micro820, the Micro850, and the Micro870. One notable feature of the driver is that its support for browsing global variables. It's worth mentioning, though, that not all the global variables are accessible through browse requests. This includes UDTs and system-defined structures, Boolean data type arrays, and arrays with non-zero starting indices. Despite these limitations, accessing these global variables in Ignition is still achievable through the addresses configuration page. Users have the flexibility to import them from a CSV file downloaded from their connected components workbench, ensuring seamless integration with the Micro800 series. That covers the IEC-61850 driver along with the Micro800 driver. I'll be back in a little bit to demo hooking these up and building a little bit in the designer, but I'm going to turn it back over to Reese to cover our other two drivers.
All righty, perfect. So we'll go ahead and jump to the DNP3 driver here. Keep this train moving. So here are some of the features of this new DNP3 driver, which was released in 8.1.36. Starting off with the class-based polling, this feature allows a device to pull different classes of data at different rates. There are 4 different classes, class 0 through 4. 0 is used for static data or integrity pulls, while class 1, 2, and 3 can be used to categorize different data according to criticality. Of course, this categorization is up to the implementation, right? But within Ignition, we can now use it to pull critical data in class 1, for example, at a separate rate than non-critical data in class 3. The new driver also supports sequence of events data. So rather than only grabbing the current tag value, the new driver allows for grabbing all the events or tag changes that have happened since that last pull. So this might not be necessary for real-time HMI applications that are pulling that data and just viewing the live current value of that. But imagine a scenario where a value might change from 3 and then 4, right? And then maybe back to 3 in between pulls. So we would miss out on that 4 value, but we can now utilize the new sequence of events capabilities to grab all the values between the pulls and really just forward those onto the database so that we can view the historical records later on while still viewing that real-time data. And finally, the third bullet, functions. There are a host of new functions to support the new and existing capabilities of the driver. I'm going to flip to the next slide here and dive into this a little bit more. This new driver is also paired with a new namespace of system.dnp.x. And the X, of course, represents multiple different functions that are available. But this really was to alleviate trying to figure out revisioning and number confusion with the 3 and DNP3, and do we do Rev2 or V2, etc. So all additional updates to this driver will fall under the system.dnp namespace. And as the next bullet mentions, the old driver scripts will still exist for those that are currently using them. So now to talk about the functions themselves, there are functions that perform similar to the old functions that were used, as well as additional functions to support all those new features of this driver. And just to highlight one of those, one of my personal favorites of these functions is the system.dnp.demand pull function. And this function allows an operator to refresh the live data on a button click event, for example, so they can see the current value and know that they're viewing that. So you can certainly see the utility of that when an operator, they want to make sure that they're viewing the absolute latest value. So that's it for the overview of the new driver there for DNP3. We'll go ahead and jump to the Mitsubishi driver next. The Mitsubishi driver was released in 8.1.28 and extends the capabilities for Ignition to connect to Mitsubishi controllers that support the MELSEC or MELSEC protocol. The majority of MELSEC device users are in Asia, but many other regions have steadily adopted the devices over the years. With the huge market in Asia and consistently growing global usage, MELSEC devices are actually the most PLCs outside of the US, and they have a reputation for being very reliable, high quality, and high performance controllers. Inductive Automation plans to continue expanding globally and foster relationships with a diverse range of worldwide integrators and industry leaders. A big part of that plan includes adding new features, functionality, and connectivity to ignition, and thereby eliminating obstacles in automation. Ultimately, the new Mitsubishi Driver extends the long list of ignition-compatible devices and increases interoperability in any system, whether your facility uses mainly MELSEC PLCs or you're looking to add functionality with additional MELSEC-capable machines. So now digging into the details a little bit here, the Mitsubishi Driver supports most of the MELSEC series PLCs, including the IQR, IQF, Q, L, and as of 8.1.35, the F series, which uses Seamless Message Protocol, or SLMP, communications through PLC Ethernet ports. Speaking of Ethernet ports, the one thing to note is that Ethernet connectivity to the device is needed for this driver. We do not support serial connections with this driver. And similar to the Modbus driver, you can address the Mitsubishi Driver through the gateway and upload a list of addresses, or through the Ignition Designer following the OPC-UA server node syntax. And so the Mitsubishi Driver also supports most data types for addressing, including booleans and integers, strings, and of course a lot more here. But for a complete list, check out our docs page on our website, but there are certainly a few listed here. These data types are prefixed as X for inputs, Y for outputs, M for internal relays, and D for data registers. The driver also supports arrays, there's bit indexing, we can reach over multiple registers to handle larger data types. And as far as addressing goes, you actually can see in this image here that I pulled from our user manual, you can see the addresses are made up of the prefix followed by the syntax for the different data types. For example, D0 under the addressing column there references all the data register 0, while D0.0 would reference the 0 bit in data register 0. You may also notice that below that we can span multiple registers for larger numbers, such as the D int 32 and angle brackets 5 there. This would span both the 5 and 6 registers because it's made up of 32 bits or two 16-bit registers.